Hey girls and boys, it's Mr. McAndrew, the math coach. So I thought I would review some of the work that you had to do on your own yesterday in case you had any trouble. All right. And the expectation, of course, is that you did do it, or at least you tried to do it. Okay. And that you didn't just like try it for a few seconds and then gave up. Right. So that's not perseverance. Okay. That being said, if you had any questions, this might be helpful to you. Okay, so let's take a look at the first page. So the object here was to help the ants, right? The ants of Antopolis, find a helipad as big as possible if they had only 26 centimeters of light to go around it. So that means the perimeter. Okay, so these are the ones that I found. I found one that was 10 by 3 because 10 plus 3 is 13. Right? If I double 13, I get 26. Now, why do I say double 13? Because if I have 10 and 3, right, then I'm also going to have 10 here on this side and 3 over here on this side, which means my perimeter will be 10, 20, 23, 26. Okay, or just take the length and the width, right? Add them up and get 13 and then double it. Okay? The area for that helipad would be 30 square centimeters because 10 times 3 is 30. You can see we have three rows of 10 square centimeters. Okay? This one I found length of 9, width of 4. Again, 9 plus 4 is 13. If I double 13, I get 26. Sorry, that's 9. If this side's 9, this side's 9, and this side is 4. So that perimeter is also 26, so the light can go around it. But the area jumped up from 30 to 36 because 9 rows of 4 is more than 10 rows of 3. Okay? I also found these. These all have a perimeter of 26 centimeters. Note that 8 plus 5 is 13. 11 plus 2 is 13. And 6 plus 7 is 13. And if I double that, I get 26. Okay, so let's find out the area of these and see which helipad is the largest. They all have the same perimeter, right? The distance around the outside, but they have different areas. Okay, and so we're looking for the biggest one. So let's see. Here we have 8 rows of 5. 8 times 5 gives me 40. So area equals 40 square centimeters. This one does not look so big, right? We have 2, columns of 11. 2 times 11 would give me 22. I'm actually going to write it this way. Area equals 22 square centimeters. Okay, and then this one up here. Now this one looks like it's pretty big, right? So if I have 6 rows of 7, right? 7, 14, 21, 28, 35. Did I do this wrong? Let's see. No, I'm counting by 7s. 6, 12, 18, 24, 30, 36, 42. So 6 times 7 is area equals 42 square centimeters. So it looks like this one here is the largest. Okay, is that what you got? Did you see that has a perimeter of 26? Right, so if I fill this in, 7 and 7 is 14, plus 6 is 20, plus 6 more is 26, and it has the largest area. Okay? This next page, I think I said was optional, but hopefully you did it. And this was different because all of the areas had to be 40 square centimeters. Okay, so the area had to be 40 square centimeters. All of them had to be. All right, and then the idea was to see what had the smallest perimeter, right? To see like what's the smallest perimeter for putting up lights, okay? So here we can see that 8 and 5 is 13. So the perimeter must be 26 centimeters. right? 26, because if this is also 8 and 5, 8 and 5 is 13, we double it, we get 26. Over here, we have 10 and 4 is 14, so the perimeter should be 28, right? Let's check. If that's 10, this is 10, and if this side is 4, this side is 4. Let's see, 10 plus 10 is 20, 24, 28. Yep. And then this long one, very long one, looks like we have 20 on this side, which means we have 20 on this side, 2 there and 2 there. That's 44. Oh my goodness, that's huge. Right? So it's a really big one. You could do a rectangle that's 1 by 40, but that perimeter would be like epic, right? It would actually be 40 plus 40 is 80. It would be like 82. So the rectangle with the smallest perimeter is actually this one. It's interesting. If you notice, the rectangles that have like the sort of like the biggest, sort of like the widest, more like closer to a square, seem to have the bigger area but smaller perimeter. I don't know. It's kind of like interesting. Kind of noticing that. Okay, and then on this page, you had 3 problems. Number 1 is an area problem. You're trying to find how much of the wall did Mr. Lee tile. So you need to do 15 times 12. Okay, that's an area problem. This is clearly perimeter number 2 because you're trying to find how much fence goes all the way around. Okay, so that's 15 plus 25 plus 15 plus 25. You can solve that, I'm sure. And then the last one is also area, because there's this like mega bulletin board at school, and the question is how much of the wall does it cover, right? So how much space does it take up, which is area. So in that case, it would be 32 times 14. All right. And what is 32 times 14? I don't know. Should we do it real quick? Let's see. We've got, if this is 30, and this is 2, this is 10, and this is 4, we have 10 times 30, which is 300. Can you see that? We have 10 times 2, which is 20. Down here we have 4 rows of 30, which is going to give us 120, and 4 rows of 2, which is 8. If we add up 300 plus 120, that's 420. Another 20 is 440, and another 8 is 448. All right, if I use the area model, to figure out the area of the bulletin board. Kind of funny, right? All right, boys and girls, hopefully that's a little bit helpful. Hopefully you're getting something out of this, doing your work, doing your best, even if you're making mistakes, but you're doing your best and you're learning from it. Your brain's growing, and that's what we're looking for. All right, boys and girls, good to work with you as always, and I'll see you soon. Bye-bye.